mate or a perfect combination of things for giving you a little bit of friction, yet still making it very smooth and making it easy to navigate. Some, if you want to keep the ball bearings, sometimes you can add a little spring tension, but to the base, it makes it difficult. It's more for the altitude adjustment of a Dob.
So here's my question. Where can I get the Teflon pads and the pebble texture that you're talking about? Because when I look online, it seems that every place seems to be sold out. So if someone could point me in the right direction, that would be so good.
How much do you need?
I don't know.
I mean, how much is how big is the surface area at the bottom of your of that base of your rocker box? What are
there's
the
it's
dimensions of the rocker box, in other words?
I'll have to send you that. I don't know off the top of my head. It feels like a 24-inch diameter diameter there, and then underneath there's like a sort of triangle shaped piece that is underneath.
How big is the mirror?
I had the same issue.
12-inch.
12. Okay.
I had the same issue, and I have a solution that worked for me.
All right, Tom.
So what I did, I replaced the bottom so I don't have the triangular part, but I used just little pieces of plywood, and I put on top of that, I glued in a piece of carpet. So just to get the right height, so it's rubbing against the carpet. It's smooth, but not too smooth, because I also put a Lazy Susan on the bottom, which made it too good. So it was moving just too nicely, so I had to be slowed down a little bit. And this worked for me. Just on three spots, I put in a small piece of plywood of the right height, and I just glued a piece of carpet on it, kind of a stiff carpet. So it's just rubbing. You may have to play around with it a little bit, but it worked for me.
That's a good idea. Yeah, it's a good retrofit. So you're adding a little friction pad, basically.
Yeah, basically.
Yeah.
I mean, you can play around with it, but it's cheap, You can just get a piece of carpet from anywhere, probably.
I'm gonna look into that. I'm gonna take it apart because I'm upgrading that scope this week or next. Thank you.
Any other thoughts? Any other thoughts for Leon's issue?
Do you have a magnet for your little counterweight to help with anything?
Yes. Oh,
you already got that, right?
So I bought some ceramic magnets and put them in a little cloth, and they magnetize to the tube so I can use my big 2-inch eyepieces without feeling like it's unbalanced. But the other thing is that the altitude adjustment is too loose as well. So I've been asking AI about that. And let me switch my camera around again real quick. And so, but here's the situation with that. It's basically just a spring, and I'm pretty sure these are Teflon pads there.
Mm-hmm.
Yeah.
And this spring, basically, maybe I just need to get tighter springs. I don't know.
Just put a piece of carpet in between those on the bottom, same way, right there. Yeah.
Huh. That's an idea. Increase the friction.
Yeah. So
one other approach could be to move the Teflon pads down a little bit. So the Teflon pads are typically positioned on a Dob such that they're kind of at a right angle. They're at 90 degrees to one another. So that if you were to make a right angle and have the pads so that they're normal at the bottom, normal to that right angle, that kind of gives you the sweet spot of sort of friction versus force pulling down on it.
You mean that the 90 degrees from the center of the circle?
No, 90 degrees relative to each other. So if this is where the Dob, if the apex of my fingers,
yeah,
is where the center point of the altitude bearing rotates.
Okay, that's what I'm thinking.
You would have a pad here. I'll do it this way: a pad there, and then a pad here.
That makes sense.
It looked like yours were a little wider, and I've seen that a lot in some commercial scopes. But when you're building a Dob, you typically are putting it at normal to that right angle, because then the forces are balanced regardless of where the tube's pointing. The forces are balanced kind of on each side of that pad. That might make a difference, and it's hard to tell from the way you were holding the camera towards the Dob exactly what that angle is, but it looked a little wide to me. Something to think about.
Thank you. I'll look into those measures. That's perfect. Good advice.
And like Tom said, a piece of carpet or something, or friction, or a stiffer spring is also a typical way to adjust something like that. You can also try putting the spring off axis too, rather than in the center, especially if you're having an issue with heavy eyepieces when the Dob's low. Because then when the Dob is lower, that's when it needs more spring force. So if you put the spring, if this is the axis again of rotation, sometimes the spring is actually off axis on the back
Okay.
side, like opposite when it's going down.
Okay.
Yeah, stuff to try.
I had a question.
Yeah, Tom.
So a few meetings ago, normally I couldn't attend this meeting at all this year, but something came up, so I can. So I listened to your guys, what you recommended about doing, not deep sky, but well, maybe deep sky in my setup. And so so I borrowed a camera from Tom Malasco, and I gave it a try. And I think I'm ready for making some purchases, but I want to share a couple pictures, two good ones and one rotten one, and see what happened and what I'm proposing to do, specifically a camera recommendation. Can I share a screen?
Should be able to. Should be a green up arrow in the bottom of your screen.
Yep. Okay, I'm allowed to do that. Can you see that?
It's coming.
Yep, or
See the
to
website?
your desktop.
Okay, so let me see. Not this one. So using the camera that Tom lent me, I took a picture of M3 at full f10, 15 seconds exposures. It sort of looks okay, I guess. So this is a really tiny frame, and it kind of encouraged me that it is possible, especially if I got a reducer, because it's really, really tight. So then I tried this one.
Nice.
And you see the camera 183 MC. So that sort of surprised me. That's not too bad, it's like, again, like 10-second exposures for, I don't know how many frames, maybe 70 or so. And then I tried this, and I could not get anything out of this thing. I mean, no matter what exposure I tried, and the object is just huge, and there's a lot of noise. And anyway, so I think I proved the concept that it's possible. It is really tiny. So my plan is to get a reducer, and I just order one. And then I'm just want to know which camera to get. And I'm leaning towards the ASI 585 MC, not the cool one, as a one to use with the reducer, and also probably can do some planetary with that. Would that work for me, you think? I'm not interested in doing deep sky 15-minute exposure. I want to do just electronically assisted astronomy. So short exposures. By the way, this is all sharp cap. Using the sequencer and the slide stacking, maybe less than 10-second exposures. And I'm interested in objects that are fairly small, not clouds. I have a C star for that. What do you think about the camera? Is that the best one for me? I don't want to spend a fortune, but
Is this for you're going to be using the 8-inch with the reducer?
yes.
And it's, I guess, is it a 6.63 reducer?
Yes, it's from Arizona. It's specifically made for an AFC graphics optics SCT. They're all the only ones I saw that sell that would give me the right back focus. In fact, I ordered it today, but I didn't order the camera. I don't know about.
Tom, when you were shooting these, did you do any binning on that camera? Did you do like a 2x2 binning? Because the 183, I just pulled up the specs on it, has 2.4 micron pixels.
Yeah, I think on this one I tried. I think I played around with that too. I don't. At least this one, not for sure. It may have been in my desperation here I was trying, but this is actually quite dimmed. It was just noisy all over the place. I mean, it was just like this. It was everywhere.
How warm was it that, or like how hot was it the day you shot this? To like ambient temperature, out of
Mm,
curiosity, approximately.
I don't know, 20 degrees centigrade. I don't know, some normal temperature, kind of nice, you know. And I shot it right after I did the other ones. So, you know, this is all,
Okay.
no, not
Okay.
the other one. The 13 was done when it was a lot cooler, I would say. And these last two, the M57 and this one, I don't know, normal temperature, I guess.
Okay.
I was just surprised that the other one was so much worse. I don't know what I did.
I mean, one is the surface, the brightness of the objects, right? So this is, you know, a face-on galaxy is going to be generally lower surface brightness than something like the ring. The ring is small, but it's fairly bright. And
Yeah.
same with the M3, you know, relatively speaking, it's a bright object, or brighter object. So that could make a difference with the noise you're seeing. So I'm just looking at the 585. So that has similar size pixels. So it's 2.9 square pixels versus 2.4. So that's
Right.
basically a wash. And what are the 183 is? Oh, the 183 is a bigger sensor.
Yeah.
So
Yeah,
540.
that was one of my concerns that this sensor is fairly small. But
Yeah.
I mean,
Yeah, the
I don't
five.
see too many other cameras options.
Yeah, I actually have the 585 MC. That was my first camera,
And what do you,
and I like it a lot. I think it is a good intermediate camera for both. It's fast enough for planetary, but it can do some shorter exposures for deep sky. You will start getting some noise issues if you're doing longer exposures, due to the heat, because it's not cooled, but that saves you money. And the sensor is not huge. So there's that, but that's also kind of forgiving because you don't have to worry so much about vignetting and other issues. First of all, great job. You're shooting at f10 and you found the object. That's already like,
yeah,
honestly,
I started using plate solving with a little help telescope on the side. So I was shocked that it just worked so well. It found normally I tried this one first and I couldn't see it. So I said, okay, I need to shoot things I can see. So that's why I did the ring.
yeah, yeah.
And then I said, well, I found it so easy. Let's try this one. And it came right in the middle of the frame.
That's
I guess
already amazing.
the other question would be for the 585, would I be able to do plate solving with the main camera? Because right now I was just using a 40 millimeter 165 with a mini cam, you know,
If
that I
you're,
have perfectly lined with the main telescope. It's just a pain to have too many things like that. You know, if you could do it with one.
yeah, you said you're using Sharp Cap,
Yeah.
and one of the more recent features as of a year ago, the plate solving is pretty good, and it actually works at a higher focal length like you're talking about. 2 years ago, Doug Lentz would be out there in Green Lane with me complaining because he couldn't get it to plate solve because he was trying to image at a higher f ratio. But seems like it's pretty good as long as you have the denser star file loaded into SharpCap, which I believe it's all
Yeah.
built in now, so it should work. Are you guiding with this or not guiding?
No, I don't think this mount
Yep.
is
So you're
it's
not guiding at
capable.
f10, so that's challenging too.
No, I mean, it's tracking pretty well, but I cannot imagine that this old mount, you know, it's gonna do that. So for example, could it plate solve what you're looking at? Yeah.
Yeah.
I guess with the reducer, maybe it will be helpful.
Yeah, the reducer is going to improve your chances of plate solving. And you will want to plate solve through the main camera because trying to keep the other guy aligned, that's
Yeah.
not fun.
Yeah.
And if you're not going to be guiding, I wouldn't worry about cooling because you're not going to be able to do long enough exposures anyway.
No,
So like an uncooled 585. Your other option, Steve Haas, he has the cooled version of the 585. So talk to Steve Haas would be another person, or look at his images.
yeah, there's no way I'm going to be doing guiding. I mean, I'm too impatient with this kind of stuff, you know. I want to see things right away.
Yeah.
What year of mead do you have?
I'm sorry?
What year is your mead, and what type of mead is it?
I have no, I don't know, maybe
LX
2000, 2000,
LX
LX,
200?
oh, LXD 90, 75.
Oh, okay.
So I replaced all the drive with on steps. So I'm controlling it with on steps, so it's all working great. And it seems to be not too much backlash, but guiding, no, I'm not going to be out there that long. I just, you know, these kind of objects, there's relatively, galaxies, I don't know, not anything big. So yeah, 585. Yeah, what else? If not, then what? What else is there?
I mean, you're not looking for a cooled camera since you're doing short exposures, but
Right.
one that I found mates really well with like a SCT is the 533
Yeah, but you talk twice as
camera.
much money.
So I think it's when it's not on sale, I think the normal price is $7.99 for it. It's a cooled camera.
Yeah.
It's a 1-inch square sensor,
Yeah.
3,000 pixels on each side, and it has 3.76 micron pixels. So it
Yeah.
it gives you a little less oversampling with your setup.
Do they have a uncooled version?
Might.
I don't know if ZWO does. It's possible QHY does. Let me see.
I think that's the camera Doug Lentz uses on his 8-inch Schmickcast. So the square one. That's
Yeah.
one you use, Gary,
By the way,
right?
there may be some other people with questions. I think I'll probably just go with a 585. It's like $400, and
It's a nice camera. I use that for planetary. I actually have the predecessor, the 485,
so I
which
can
is
use.
like I bought it probably about 6 months before the 585 came out. The 485 wasn't around for long. It's the same geometry. It just is a less well depth and a few other features like that. A little noisier than the 585, and it's a great little camera.
Yeah. Okay.
And you can
And
do binning with
Doug
that.
just joined actually.
Sorry.
Doug just joined. If
Oh.
Yeah,
Okay.
Doug. We're just speak of the devil, Doug. We were just talking about you. I don't know if you're muted, but
yeah, he's muted. There now he's unmuted.
There.
We were
Oh,
just
and
talking
I
about
even
you,
look
Doug. We were
like-
talking about
I even look like the someone coming from the underworld.
Yes.
Drew. You're very stealth.
I'm
Very stealth.
Doug.
And we were wondering if you were using which Tom Skrovanak is talking about purchasing a camera, an uncooled camera, for doing some deep sky with his
Okay.
8-inch SCT with a focal reducer, and he's looking at the 585 MC for that. And then we also talked about the 533 MC, which is a cooled camera, and we were just wondering what camera you've been using or you have used.
Well, first of all, Tom, if you just I think if you just wait until about December, it becomes a cooled camera.
Oh, okay, cool.
But no, I used the 294, which in my case, which is cooled. You might be able to, there might be an uncooled version though.
294. Okay.
is that a square one?
No, no, it's a rectangular one.
Okay.
Let's see.
And does the new version of SharpCap work well for polar alignment with your SCT, Doug?
Oh yeah.
Okay.
Well,
You used to have problems with it.
yeah, oh, I used to have a lot of different, but I have different problems now. No,
Oh,
it
good.
works. I usually polar align through a guide's, I polar align through a 200 millimeter guide scope.
But the
That's
plate
what I,
solving work is good now?
Yeah. And but I don't have any problem plate solving at all at any focal length that I use.
Okay.
even like 1300.
Oh no, I don't have any problem at all. You might have to, if you're using SharpCap, you might have to download an index file.
Yeah.
Yeah, I think
But no, it plate solves just fine.
yeah, I do polar
From
line.
anywhere. It plate solves from where I live. It said
Okay.
it almost plate solves in the daytime.
Oh, wow.
It's that it's that good.
Okay. Yeah, for now I've been using a little small scope to polar line, and then I just put it away. But I
Yeah.
don't want to have two things like that. So okay, that sounds encouraging. Okay, I think I'll just go purchase one and
Yeah.
always sell.
Well, I mean, it's even if you find that you want something later on for deep sky, the 585 is a great planetary camera.
Yeah, I have a 662, so it becomes redundant. Maybe I'll sell that one.
I actually use the 585 for my guide camera. Even though it's color, it works fine. So
Mhm.
if you do decide to guide, you can keep it.
Yeah, I'll keep it. It's prices have gone, and so I can probably sell it for what I paid for.
Nice job, Tom, with those.
Yeah.
That's
I was
impressive with
particularly happy with this one. It's like, whoa. The stars are not perfect, but with that mount, not bad. Okay, I'm done. Thank you. Thank you. How do I unshare? Oh, stop sharing.
yeah,
All
stop
right.
share. Yeah,
All right, great. Thank you.
cool. Any other questions before we get into the regular part of the meeting?
Mm, For guiding is with a guider is about half pixel accuracy and PhD pretty good? Or do you have to worry about the arc second? What should I be looking at? The arc seconds or the pixels?
The full width half max. In SharpCap?
No, PhD.
Oh.
What is the question again?
Oh, the arc seconds error RMS. Like under
Yeah.
0.6 is good.
In arc seconds. Okay.
What do you think, Gary?
Yeah,
0.6?
I
That's
usually
like a good
shoot
night.
for. Yeah, I usually shoot for around that. I'm usually in that point 5, 0.6, 0.7 range. Sometimes on a really good night, it's a little bit less in terms of RMS. One thing that you want to kind of keep an eye out for is if you have any major corrections in one axis. Like if you're seeing really big corrections, there's that little graph that shows you the instantaneous corrections. If you're ever seeing something like real large deck corrections, like spiky kind of things like that could be indicative of something with your mount, like maybe when the axis needs to be a little better lubricated or something like that. It's just something to keep an eye open for, assuming it's not a windy night or something like that where you have outside factors like that.
I have a similar scope to Tom's. I have a 8-inch LX200, and I put it on the table the other night with I got a QHY Minicam 8 with the filter wheel integral, and it actually swings through. I was so happy. It doesn't have a reducer on it, but I'm out for the tiny objects. Like Able 39 is my goal at some point in time. It's an amazing little object. If you know Abel 39,
Not
It's a
offhand.
blue perfect sphere, about the same, slightly larger than M57, but it's and it's fairly dim
Oh.
too.
Is
I'd like
yours,
to try that one,
are you on equatorial or fork mount?
equatorial. But yeah, I haven't completely integrated the Meade drive with guiding yet. I have a ST4 cable I made up with my multimeter out, checking the voltages and everything. Prasad, you'll be interested to know that. But it's all set to go. I just need a night and take 70 pounds and lift it up and put it on the wedge. So it's in the offing.
On the edge. Are you using the original Meade drives for them?
Yeah, it's a 1995 I bought it.
I mean, I threw those things away. As soon as I bought mine, I put on step on that.
Really?
Yeah, it's
Oh,
fantastic. I mean,
I'll have to look
unbelievable.
that up.
Sorry?
It's an electronic package?
Oh yeah, it's all remote ASCOM and all bell driven. It's super quiet.
Oh,
Unbelievable.
I'll check it out. I replaced all the capacitors that self-destruct the unit, so it's all safe.
Yeah, no,
But,
I ruined mine right away. Reverse polarity, but I had to restart some things. And after that, and after listening to that, going like,
Yeah, the wine. The wine of the old Meads.
yeah,
Yeah.
you can ask Prasad. He also has an on step on his. It's a beautiful system and it's cheap too. I think I
Really?
paid like $200 with a hand controller.
But the the internal electronics too?
Yeah, everything.
No, everything.
Yeah,
Oh.
everything, including the motors and the belts and the brackets and hand controller.
Huh. I'll have to look that up.
You should get together with me sometimes. Show you. I can show you some pictures what it looks like. Maybe it doesn't apply to your mount, but
Oh.
it's a kind of Vixen style or ECOS 2 kind of mount.
My mount? No, it's a fork mount.
Fork mount. Oh,
Yeah,
okay. I thought you said it was not, it was like
it's
an equatorial, German equatorial now.
no, it's on a wedge.
Yeah, I mean, those people have replaced those. I can point you to zillions of people have replaced and put on the web. There's a whole community that they have converted a whole bunch of scopes. Mine was the simplest thing, just one board. But yeah, I've seen those too.
I had deforked the tube and put it on my German mount. And I put it back, but my goal is to have the old 30-year-old mount. I'll see what I can do.
That's the
playing
one.
around.
That's the one that would be a good candidate. Let's get
Hope so.
together sometime.
Yeah. All right.
And Leon, Nelson, if you go back, if you go onto the YouTube channel, the DVAA YouTube channel, go back to the it's the September 9th workshop, 2025, September 9th, 2025, astrophotography workshop. Tom did a presentation on converting. You did the PC, and I think you also, Tom, talked about the one-step controller as part of that, if I'm not mistaken.
Yeah, the on step X. Yeah.
Yeah.
Yeah,
So
maybe there are some pictures.
One step. So there's some additional information there if you go back to that presentation.
Okay. Thanks.
I'll take a look, see what I put, if I put any pictures there. Okay, great.
Cool. And it looks like there's a Tom Kildea on the workshop. You're currently muted. Are you a new attendee?
I think I've seen Tom before.
Yeah.
The name's familiar, but I'm just okay. He might be away. He might be away from the computer. So, okay.
Hey, Gary.
Yeah. Hi, Prasad.
Hi. I just wanted to, okay, it took a little time for me to get my audio and video going. Just wanted to say that, I've been playing around with the on-step for several years. Converted several mounts, including making a complete mount on my own. So I'm very familiar with that. That's all.
You have some good resources here, Nelson.
Thanks.
The presentation you mentioned, Gary, does not talk about the OnStep or anything like this. Is all equatorial platform that I built for my jobs. I just looked at the presentation.
Okay.
Well, it talks about the friction thing. Maybe somebody can look at it.
So Nelson, don't go to the 2025 September 7th.
Yeah, I mean, we could do a private Zoom session. And Prasad too. I mean, Prasad is a bigger expert than I am, actually.
Yeah, I'm sure.
I just did one. So anyway.
So
Okay, so let's jump. We'll have some time for show and tell and Q&A, additional Q&A later on in the meeting. Let me get some stuff out of the way here. That's what happens. You open up browsers when people talk about cameras and stuff like that. Now I got to get them out of the way. There we go. So let's get this over here. And I'm going to share my screen. Okay, so tonight's meeting, we're going to talk about, I'm going to do a presentation on processing, on image acquisition, but mainly processing a rich field version of M13 using PixInsight. And then we'll have open session for any recently acquired or processed images, new equipment or techniques. So as far as M13 goes, this is the final image shot using a RedCat 51 with an ASI 2600 MC camera. And even though it's incredibly wide field for that object, for such a small object, if you zoom in, this is the same picture, just zoomed in. It's amazing how much detail is in that core, even though it's shot wide field. This is Drizzle 2X, which we'll get into later on. So we're going to talk about how I process this image. Next month, we're going to have a presentation by Bill McGeeney on the Star Trails image that he took at Raystown Lake. So Bill will be talking about planning that image, executing it, and then processing that. The month after that, on August 26th, Brett has volunteered to do a presentation on the recent trip that he took to the Atacama Desert. And I'm assuming, Brett, you'll be showing some images and things of that sort in addition to some of the highlights of the trip.
Yep.
And then the following month, we have a presentation by Nico Carver of Nebula Photos. And then October's an open session right now. There was some talk, there was a suggestion last month about possibly reaching out to Agapios, since the planets will be sort of in close to opposition in that time frame. So that nothing has been done with that at this point, but that's just up in the air. And then possibly in November, this is still question marks. Wayne Reed had talked about doing a presentation, getting started with Cyril for image processing. The December 16th meeting, I'm going to leave as an open session. I will be out of town for that meeting, so I'll need someone to kind of run the meeting that month. So I'm just putting out a feeler. If someone wants to have a topic, that's fine. I'm just leaving it open since I know I will be out of the country at that point. So again, in the July meeting, Bill will be talking about this, how he executed this and processed this image. And Brett, I grabbed these screenshots from when you were talking about it last month. I grabbed the videos. So this is two images that Brett, preliminary images that Brett had taken while he was on his trip. And then this is Nico's website, so people can learn more about Nico Carver. Okay. So that's upcoming stuff. So as far as tonight goes, I'm going to talk about the image that I showed you of M13 shot with the Red Cat. So just some background information, the equipment I use, processing workflow, and then actually a live processing demonstration using PixInsight. And the tools are very simple that I'm using. And so anything with Serral would be, using Serral would be applicable. So a while back in 2022, let me start off by saying M13 is one of my favorite objects. I've been taking pictures of it from the film days with my DSL, with my SLR hanging on the back of my telescope. But this was one shot at Blue Mountain Vista back in 2022 with a C9 1/4. So this is shot at around a little under 1600 millimeter focal length with an APS-C size sensor. So fairly close, fairly tight shot of M13. It's about an hour and 10 minutes of exposure time, calibrated with flat starts and bias, and with the focal reducer on that OTA. And then 2 years after that, I decided to shoot it with my TV85, which is a 480 millimeters with the focal reducer on it. So the core is much, much tighter, obviously, because it's a wider field of view. This is only 53 minutes worth of data. Then last month, I happened to go up to Hickory Run State Park, and we had a reasonable night. It was some high, thin clouds, but nothing, no big clouds floating through. It was hazy. It was one of those when we had that first heat wave back in May. So it was in the 90s. So at night it was probably 80, like at the beginning of the night. So it was a hot night. This is a cooled camera. Camera had a hard time keeping up with the cooling, but it worked. So this was shot with a Red Cat 51. So this is 250 millimeter focal length. So it's essentially half the focal length of that. But it's shot from a darker site. The middle one was shot from my backyard. This is shot from about a magnitude darker than where I live. And it's also a longer exposure. This is almost 3 hours worth of data. So 2 hours and 38 minutes worth of data. And again, if you zoom in on that core, so this is the same exact image, just zoomed in on that core. This is probably the most surprising thing that hit me when I zoomed in, that you could still resolve a lot of those stars from such a really wide field of view image. And I think part of that is the telescope. Those Red Cats are surprisingly good optically. It kind of blows me away that this tiny little 51 millimeter, 2-inch refractor has sharp stars corner to corner, and it can also have that kind of resolution. This is Drizzle 2X. And we'll get into that in a minute. So this is the equipment that I used. I had an AM3 mount, so it's a relatively small. I leave all of this put together. So this whole thing I just leave put together. I unplug here. I unplug these two cables here, and I loosen the dovetail and I slide it out, and I stick that in a plastic tote. So when I go somewhere, I literally have very little setup. I take that out of the plastic tote, slide it on the mount, set up the mount. I could literally be up and running in about 15 minutes, including polar alignment. So I use it in my backyard a lot because I can just carry it out. I can leave it set up, carry it out. The whole thing probably doesn't weigh more than about 20 pounds, something like that. Maybe a little over that, 25 pounds. So again, this was shot with the Red Cat, the ASI 2600. It's an APS-C sensor. I've been using very religiously, unless I'm in a really dark sky site, this Optilong L-Quad Enhance. It's a quad band filter, basically a light pollution filter. I have a small 30 millimeter SV Bony guide scope. Actually, on this shot, you can see that. So there's the guide scope, a little ASI 120 mm mini camera for guiding, and then the ASI Air is sitting on top. So that's the whole rig, including basically the computer. And I run it with my iPad or my iPhone. So from a workflow standpoint, and before I go on, any questions about any of that, the equipment stuff, or? Okay, so from a workflow standpoint, this is just my approach to processing this image. It's just purely based on what I've learned from others along the way and my experience with using tools that give me predictable and consistent results. There's a lot of tools I don't use because I haven't either learned them well enough for them to be predictable or consistent. And for me, being able to know what a tool is going to do and is a huge part for me being able to control the process of post-processing, or the act of post-processing. It's meant as a guideline only. I always encourage people to experiment. I've learned a ton through experimentation. It's obviously one of the fundamental things involved with learning, is to experiment. So from a workflow standpoint, this is a very simple workflow. So I do, in PixInsight, it's called weighted batch pre-processing. That's basically stacking and calibrating the images. I then first do a gradient correction. I then follow that with a color calibration. I then use some type of deconvolution. I happen to be using Blur Exterminator very, very regularly now. I used to use there's a processing suite called the Easy Processing Suite, which is free. Blur Exterminator is a paid thing. The Easy Processing Suite has a deconvolution, which worked quite well in the past. For this image, you probably wouldn't even need Noise Exterminator, but I did use it on here, so I included it in that. And this is all basically part of the linear processing workflow. So we've talked about before linear versus nonlinear. So linear processing is when nothing is stretched. As soon as you stretch an object using, say, something like a histogram transformation, or curves, or a general hyperbolic stretch, any of those methods, you make the image nonlinear. So as far as nonlinear processing, you start with that linear image from the previous slide. I applied a histogram transformation 3 times, like a mild one 3 times. I then did a generalized hyperbolic stretch. I then did another histogram transformation and then a black point adjustment. I then did a curves transformation to just tweak the contrast a little bit, give it a little more punch, and increase the saturation to give the stars a little more color. And this I didn't even do. I didn't need to do a final, but sometimes you'll need to, after you do a curves, you may need to do a black point adjustment again. And then for this image, since I drizzled when I did the integration, I resampled it at 0.5x to give me the final image. From a PixInsight icon standpoint, these are all of the steps that I just mentioned. So what I do in PixInsight, and somebody would need to tell me if Cyril has a similar ability, where when I do an operation, I actually save an instance of that operation and I label it so that my workflow is actually this way. So gradient correction, spectrophotometric color calibration, blur exterminator, noise exterminator. The little R means I dialed it back from the defaults. Histogram transformation, 1, 2, 3 times, the same exact one. Sometimes I'll do 1 and 2, and then the third one's different with the black point. General hyperbolic stretch, another little stretch, histogram with a black point adjustment, and then the contrast saturation, and then resampling. I do this because if I get here and I don't like what's happening, I can easily go back to a step and just drop those icons into the image, and it'll reprocess it. So we've talked about this weighted batch pre-processing before, and this is what PixInsight calls it. I thought I'd just spend a couple minutes here just to explain what's going on here. So I've loaded bias, a master bias, a master dark, and a master flat into this. I had other images that I had taken using the same exact setup, and I already had processed those. So instead of putting in all of my flats, like my 40 flats and my 50 darks and my 50 bias, all I did was load up the master, and I'll show you how that's done. And then these are the light frames. What I wanted to point out here for PixInsight users, because I just learned this recently, and it's kind of one of those could be a gotcha type of thing, is this little thing here. When you're in your calibration tab in PixInsight, there's a thing called calibration settings. And if you notice here, there's this little box that I have unchecked called Optimize Master Dark. And I believe the default of this panel is to have that unchecked. So I did a little research a couple weeks ago, about 3 weeks ago. It was like, I don't know if I even noticed that little checkbox before. What does that mean? And or at least my understanding of what that means is that if you're using master darks, darks that have already been summed together and calibrated, like for instance, when you're doing a master flat, the bias is subtracted from that master flat. Then you leave this unchecked. If you're using raw flats and raw bias and raw darks, then you check that box, and that optimizes the creation of the master calibration frames. So the takeaway here is that if you're already using master calibration frames, to leave that unchecked so that you're not trying to kind of readjust your calibration frames or subtract the bias out of them or something like that.
Don't mess it up.
I tell you, I doubt it would do much because these cameras are so quiet. They're not very noisy. I'm using a cooled camera also, so it's relatively low noise. These were shot at minus 10 degrees C. That was and it was running at, like I said, like 100%. It was the cooler was as much as it could do. In the beginning of the night, it was about 2 degrees C shy of minus 10, and as the night cooled down, it got to the minus 10, and then obviously the power went down for keeping that. So anyway, this is just more like something to be aware of. The next thing is the drizzle. I wanted to just talk quickly about the post calibration, where you set up the drizzle. So in the post calibration tab of the weighted batch preprocessing, there's this drizzle configuration panel here. And I'm sorry, this is supposed to say 2. I forgot to change it to 2. When I did this image, I drizzled at 2. When I'm doing images, certain images that are better sampled, like in other words, I'm not undersampling them significantly, I have done drizzle at 1. So it doesn't increase the size of the image, but if I have a lot of frames, you can do a pixel shrink to tighten up your image a little bit, even if you're not increasing the size of the image. For this particular image, the M13, since it was significantly undersampled, like the image scale for this image was about 3.2 arc seconds per pixel. Ideally, for a deep sky, you should be around 1.25 arc seconds per pixel with our seeing conditions. So I apologize for that. This should say 2 here and here for this particular image, even though this is a valid setting. So just to talk again a little bit more about the drizzle. So this is a blow up of the upper left-hand corner of the core with the 2x drizzle. Now keep in mind that the computer interpolates. So the computer, you'll see when we go to PixInsight in a minute, that this comparison is a little bit apples to oranges when you're looking at it on a computer screen because of the fact that the graphics card in this is going to try to interpolate. But you can still see, even when I do it, this is the drizzle. So this is out of the stack. And then this is the drizzle and then resampled 0.5x. It's actually very, very comparable. When you look at these, you can see the stars lose a little bit of their definition. They get a little chunky compared to nice round stars. This is zoomed way, way, way in. So keep that in mind too. You see this little chain of stars here where my cursor is above that bright one. If you look at that same chain, it's a lot, muckier. You don't see the 4 distinct stars, 1, 2, 3, 4. It's kind of like a little blob there and a little blob there. So drizzling absolutely helps in terms of resolution. You're basically doubling the resolution when you're doing that drizzle factor of 2. And for an undersampled image like this, it brings the sampling to about 1.6 arc seconds per pixel, which isn't too bad. So we'll see that a little more when we get into the actual demo. So I'm going to escape out of that. Let's get that out of the way. Let's bring up PixInsight. So from a PixInsight standpoint, those are those same icons that I showed before. And let me load up an image here. So this is actually, before I do that, I'm going to just open up that weighted batch preprocessing to just show you the bias and the lights. I believe they're still loaded in here. I had done it earlier today. They should still be there. Yeah. So here I have a master bias. Here I have a master dark. Here I have a master flat. And then I have 79 2-minute exposures sitting here. And then this is that calibration. So if I click on this, it lights up the flat and the dark. These are already calibrated, so I don't technically need the bias. If I took the bias out, it wouldn't make any difference because the flats are already calibrated. And then the post-calibration, this would go to a 2 for what I did with that image. You can see it's 2 hours and 38 minutes worth of data. So I loaded that stuff up. I let it run. I think it ran for about 50 minutes or something like that. And then what popped out, actually, I'm going to go back one more step. What popped out, let me get that down. What popped out is this. So PixInsight creates 3 images. One is your rejection for the bright stuff. I'm going to do a screen. This is a screen transfer. I'm going to uncheck. I'm going to unlink the channels so it doesn't look all green when it's auto stretched. So you can see here how many satellites went through that image. I'll blow it up a little. So all those little streaks are satellites that the fact that I had 79 exposures, and statistically this is just occurring on one exposure. The data, the software is smart enough to realize that that's extraneous data, and it pulls it out. Sometimes there's a little motion in the stars, tracking errors, things like that. It'll actually reject that stuff too. So this is the high level rejection. It's a feature in PixInsight. The low level rejection you can see is basically just background noise, so it's essentially nothing. And then where I dithered, you can see that this would be cropped out. And then I have the actual frame coming out. You can see the gradient in that. This is the undrizzled version. Then I did then it processed the same thing drizzled, which is this, and then auto crop. PixInsight has an auto crop so that when you're dithering, when you're moving that camera around between exposures, so that any hot pixels don't stay in the same spot, and any background noise is not in the same spot, then that creates that border that needs to get cropped out. And it's actually important to crop that. I crop that out. I've seen some people not do that. And one thing you want to be careful of, if you don't crop out that white or that gray around the outside when you're dithering, or if the exposures aren't exactly lined, what that does is that can fool your tools. So if you're doing like the spectrophotometric color calibration, things like that, you have bad data around the edges of it that's getting factored into the calculations. So cropping that border out, that bad border, is actually an important part of the process. PixInsight about a year and a half ago or 2 years ago, whatever it is now, wound up adding that as an automatic feature since it has the information already. So if you notice here, the gradient. So even though this was at a relatively dark sky site, and M13 was almost overhead, there's still a gradient, a sky gradient in that from left to right. So the gradient correction that I use is the default with one exception. So I do this, and I have a bigger picture of that. Let me just pull that up. I have a bigger image of that. One of the things I noticed, this is their built-in gradient correction, is there's a checkbox here called automatic convergence. In the default setting, that's not on, that automatic convergence. And some people say, oh, well, you can just run it a couple times. Well, it turns out if you click that checkbox, automatic convergence, it'll run the algorithm until there's no more gradient. So it'll actually do multiple iterations until it doesn't sense any background gradient anymore. So in order to execute that, I can either grab this little triangle and drop it onto the image, or I can just grab the icon itself and drop it onto the image. Either one does the same thing. So that instance of gradient correction we're going to run right now. And if you look here on the right, the process window, you can see it says iteration 1. Then it's going to fix the gradient. Then it's going to look at it again and say, I still see some gradient in there. And it gets faster and faster. And it gives you the delta between iterations. It looks like it did 4. Let me pull that back up. So 3 iterations, it converged. And if you look at the before and after, so that's before the gradient correction. And that's after the gradient correction. So you can see it did quite a nice job at getting rid of that gradient. The next thing I'm going to do is a spectrophotometric color calibration. And these steps are the same pretty much no matter what image I'm dealing with. Sometimes I'll use a different type of gradient correction if I have, my SCT has some weird aberrations in it that give me some ghosting. It might actually be reflection inside the tube. And sometimes I wind up using it's called a dynamic background extraction gradient correction for that to be a little more subtle in terms of controlling it. But I tell you, for 90% of what I do, I use that automated gradient correction, and it comes out fine. For the spectrophotometric color calibration, I have this sensor in. That camera uses the Sony IMX 571 sensor, very common sensor. Here's the 533, and then it has has a Bayer mask on it, so that's the color mask there. And I basically have everything else set at the defaults. So the only thing I've changed is I put the actual sensor in and then the RGB filters that are on that Sony sensor. Same thing, I can drop this little triangle onto that image and we'll let it do its color calibration. I'm going to actually run this so you can see the before and after. So right now it's basically measuring the stars, fitting the stars. So it grabbed 9,100 stars in that image to do the calibration, the color calibration. It's going to fit 10,875 stars now. So it grabs some more. And now it's done. So it goes to the Gaia database. It looks up those stars and says, what are those colors of those stars supposed to be? I'm going to now adjust the histogram RGB channels to match, to make the stars in this image match what they're supposed to be from a space telescope looking at those stars. And this is the curve showing you how well it fit those stars. So this is an ideal, the straight line would be an ideal. And this is the curve fitting from those 10,000 stars or whatever it wound up grabbing. So if you look at that image, right now it looks weird. And that's because when we first did the auto stretch, we had unlinked the RGB channels so that wouldn't look all green because of the RGB matrix. So I'm going to link the channels now. Now that it's calibrated, you want to have those channels linked. And everything you do, unless you're dealing with false color like narrowband, if you're doing RGB, you want to have that linked, because if you don't link it, you're going to wind up breaking that calibration. So now I'm going to run the auto stretch again. And that's what it looks like calibrated. So stacked. Now it's overstretched right now. That auto stretch is very aggressive. If you wanted to, pull that down, you could bring that down a little so that you're not blowing out the core. But we'll leave it at the auto stretch. We'll leave it what it thought. That's fine for now. So the next thing we're going to do is the blur exterminator. It's basically a deconvolution. Now I'm not going to actually run that. I did it earlier today and it takes about 2 minutes. So rather than do that, I have it sitting here. Yep, I'm at the wrong page. Oh, here we go. So this is, it'll get there in a second. There we go. So that's after the blur exterminator. And the settings that I'm using for the blur exterminator are these. So the default is 50, 10, and 50, or 0.5, 0.12, and 0.5. In this, since it's stars, it's an image of stars, I wound up increasing the star halos a little bit. As you know, most of the color from a star is from the halo, because the center of a star is really bright, and that's usually white or sometimes saturated. But you pick up the color, most of the color, unless it's a dim star, you pick up most of the color from the star halo, even in a bright star. So by goosing that about 20%, I'm just increasing slightly that star halo to bring out a little more color in those stars. And so this is still noisy, but just to show you, let me pull this up, and then I'll make this the same field of view as that. So you can see that basically tightened up, that blur exterminator tightened up those stars. So we'll go to this area here. And you can see here it's not excessive, but it makes a difference. It really helps clean up the stars. And that's basically a deconvolution technique. If this were a some type of a diffuse nebula or something like that, it would actually sharpen the details in that nebula, in that diffuse nebula. So then the next thing is going to be noise reduction. And similarly, that took like 2 minutes and 40 seconds to run. So I'll just drop that on. Oh, come on. And the settings that I use for that are here. So this is reduced. The default is 2 iterations, 0.9, 0.9, 0.9 with these turned off. So it's actually just 0.9 and 0.9. So I have like 4 different versions of noise reduction that I use. I typically never use the default. I find it a little too strong. This is still relatively strong, but it's a little more natural looking to me, a little more pleasing to me, to not have it look too denoised. I also increased the iterations to 3. The default's 2, because when you increase the iterations, it actually does a little less each time it iterates it, a little less noise reduction, so that you're not kind of applying it heavy each time. You're applying it a little less each time, is my understanding of how that works. It goes up to 5. I generally don't use 5. I just have it on 3. So this is the noise reduced version. I'll go into that same area. I'll bring this up to the same field of view. You can say it made a significant improvement in getting rid of a lot of that graininess in the background. Get it apples to apples here. Not overdone. There's still noise in there. You can still see noise. You can still see some background texture in that sort of halo of the globular cluster. Again, we're zoomed way in. But the image holds together, even zoomed in like that. So at that point, I'm finished linear processing. So we have it noise reduced. I'm going to close that. Yes. We have it noise reduced, and the blur exterminator calibrated and the gradient corrected. Now we're ready to stretch it and turn the image nonlinear. So any questions up to this point as far as the linear processing goes? Okay. So the first thing when I'm going to stretch it, I'm going to use a histogram transformation. And I do that to get the image. So if let me turn off the auto stretch. So if I turn off the auto stretch, that's what the image looks like. There's probably a few bright stars. Yeah, there's a couple of bright stars that are likely saturated. Yeah, so there's a couple saturated stars. These are 2-minute exposures, but not too many. There aren't too many in terms of that whole star field of 10,000 stars, not counting the globular clusters, you know, however many half million stars are in there. So the first thing I'm going to do is auto stretch. So I'm going to show the histogram, and by showing the histogram, you can't even really see it because it's way there. If I stretch this scale, that's the histogram tucked way down on the edge. So the first thing I'm going to do is, if this were on its default, it would be there. Is I'm going to pull that slider over somewhere in that range, and I'm going to put the preview on, and you can see here, you can see the core comes up a little tiny bit. If I zoom in on that, you're starting to see something there, and I'm going to apply that. Now, if I do that same thing again, that's what you're going to get. I'll zoom in on that. And we're going to do it again. And you can see now the histogram's coming over. If I zoom in again, you can see we're not saturated on even those bright stars in the core. 70, 80%, 50%, 60%. So there's still some margin to go. I'm going to give it one more stretch. I'm going to zoom in and kind of see where I am. Still, we're about even on the bright stuff. We're in the 90s, 90%. And you can see now I have a histogram that's at least somewhere out of the noise floor, out of the background black. So this part here, this histogram here, is what we're going to be working with. So I'm going to close that. And the only reason why I do that histogram transformation is because when I go to something like a generalized hyperbolic stretch, which you can use right from the beginning, I find it much, much easier to have a histogram that's kind of, that I can at least see and is in a reasonable place for me to then tweak a little bit further. So I'm going to, oops, I'm sorry. I wanted to leave that open. So now we're going to open up this. And I need to hold on 1 second. I want to get back to my baseline here. Okay. So I'm going to just apply those 3 histogram transformations again to that base image, because I was playing with the controls, so I don't want to kind of break the rest of the workflow. So that's the 3 histogram transformations that we did. Again, if I zoom way in, you can see that we're sitting about 90% on some of the brighter stuff. Now I'm going to apply the generalized hyperbolic stretch. And this, I was very aggressive on the local intensity when I did this. pulling that up. So a very common thing would be to adjust the black point first on that to get that histogram to be further down, but I'm going to do it afterwards. So if I apply the generalized hyperbolic stretch, I'm protecting my highlights here. I've pulled the highlights down. I'm going to get rid of the preview. You can see that background, the background is way, way, way up because of that. But I have my highlights protected. I went through this last.
Ready to connect.
I'm sorry. I went through this last month.
Shutting down.
And so, oh, that's somebody's sea star. Sounds like a sea star shutting down. And now here, if I adjust that black point, again, typically I would do that ahead of time. Before the GHS, I would do the hyperbolic stretch. I mean, the histogram transformation, adjust the black point, then do the GHS. But I wanted to keep this exactly how I processed it. You can see here, that's now just shifting that by moving that point over. I'm shifting that curve to the left, that histogram to the left, to get rid of all that background gray. And there's also a little bit of a stretch. You can see the curve got a little wider because I have a little bit of a stretch here. If I bring that down to here, you can see that this is not in the center anymore. It's a little bit over. And then I'll apply that. And then we have this image. So again, the core is still relatively defined. I'm about 97%. So it's about as bright as I want to go. There's a little bit of headroom. So stuff's still not saturated. You can see those numbers that are moving around. 97, there was a 99.5. So I do that to just try not to blow out the core. There's going to be some brighter stars here that will be at 100. That's like 99 point something. But that's okay. You're going to have some super bright stuff in there. Then the last step was to do a curve. So I'm going to show the histogram. So that's our histogram now. And if I this purple line is the saturation. So I'm going to increase the saturation a tiny bit. That'll add a little more color to those stars. So if I do before and after. So I'm going to reduce the background a little. If you look, that would be before. That would be after applying these curves. So let me just show you actually live. So if I reset everything, if I pull this down a little bit, you can see the background gets a little darker. And if I pull this up a tiny bit, the image gets a little bit brighter. That's actually increasing the contrast in the image without doing anything significant to the brightness of those stars. They're still not saturated. And then if I go to saturation, I can grab that and I can just pull it up a tiny bit just to increase the color of those stars a little bit. Brings out the blue a little more. It's subtle. Brings out the reds a little more. And then I'll apply that. So that's the whole image processed at this point. So linear to just get rid of the gradient, color calibrate it, tighten up the stars, get rid of some noise, and then multiple levels of stretching, a little bit of contrast enhancement, and it is stretching it a tiny bit more, and then saturation to get the final image. So this is now still the Drizzle 2X. So I'm going to duplicate this image. In PixInsight, I can just grab that little title bar and bring it over here to clone the image. I'm going to clone that image, and I'm going to make it the same field of view. You can drag that in and get the same field of view. And now I'm going to resample this one. I'm going to basically resample it by half. So effectively canceling out the 2X drizzle. Now it's saying some of these side effects are irreversible. It's going to lose the astrometric solution. So right now it knows it's plate solved, and that plate solved data will go away when I resample it. But that's okay. So that's going to resample it by a factor of 2. And let me get the same field of view again. You can see the difference here. This is without the computer screen or the graphics card. Like when I showed it to you in PowerPoint, they looked almost the same. But when you really look at pixels, this is looking at actual pixels now in that image. It's not interpolating those pixels like your computer screen and graphics cards doing. So you can see here the Drizzle 2X versus the non-Drizzle. If I take this exact image and save it as a JPEG, I'm going to show you that. That's the exact image saved as a JPEG. See how much better it looks? That's a computer making it look better. This is still resampled 0.5x. So Drizzle 2x, resample 0.5x. But right now the computer is, till you get really in there, is kind of making it look better than it really is.
The advantage is a smaller file.
In terms of the doing the resampling, yeah.
Yeah. Oh, okay.
Yeah, I mean it's one quarter the size.
Right.
The file's 1/4 the size. Yeah. So this is the. So that's what the computer is showing versus what the pixels really are.
Huh.
So that's something to keep in mind, because when you're looking at it on your computer screen, you know, the graphics engine of that system is doing something, so that when you zoom in, it's making it look better than it really is. If I were to open this in Photoshop and zoom in fact, why don't we do that? Just to drive the point home. So I'll open up Photoshop. I'll drop that same image into Photoshop and zoom in. Now you can see the pixels. Now it looks the same as that. That's this section here, this section there. Right? It's the same image.
Yeah.
Yeah, I resample it at the end because it's significantly smaller file. And keep in mind, you're looking at it like that. You're not looking at it like that. Typically, right? That's the image. That's the final image. I'm looking at that tiny globular cluster, which is, obviously the biggest one in the northern hemisphere. So it's a big globular cluster, relatively speaking. But in that field of view, it looks relatively small. So that's that.
That's very nice. Gary, could you do it again with red, green, and blue and a mono camera for me?
Sure.
Just kidding.
Yeah. So from a
Lucy, where are
So
you?
as far as obviously there's this talk tonight, but I also did a very similar workflow with M71, which is a relatively small, faint globular cluster back in September of last year, September 3rd. So this link here, or if you find that thing, go to 34 minutes, around 34 minutes, is that presentation. And that was this object here. That's it.
Nice.
Right,
stay
right.
here.
Do you find that you get a better end result doing the drizzle, doing all your processing at 2x, and then doing that final downsample, as
Yeah,
opposed to just doing everything straight at 1x?
I do. Yeah,
Yeah.
I've run that experiment.
Yeah.
I also ran an interesting experiment. I thought maybe I'd show this in a future meeting or something. I ran an interesting experiment with binning. I took the same data. I'd software binned. It was with my C6 with the 533 camera. So it's oversampled. It's 0.5 arc seconds per pixel.
Yeah.
And I wound up processing it without binning it. And then I binned 2x and did the same exact processing. And it actually looked like noticeably better by binning it first.
Really?
Yeah, like noticeably better. And even though I was shooting in a relatively it was in my backyard, so it was relatively light polluted. So there's going to be noise, right? Light pollution's noise. Binning should help the signal to noise ratio
Right.
by combining those pixels. I was way oversampled, even binning 2x on 1 arc second per pixel, which is still somewhat slightly oversampled. But I was really surprised how noticeable the difference was. And I saved some screenshots of that. Maybe in a future thing, I'll just put a little 15-minute thing together to just kind of show that as an example.
And you were using Blur X, I assume, with that one too, right?
I
Blur.
was, yeah. I
Yeah,
did
okay. That's funny because that's like the opposite. In a way, drizzling 2x is almost like unbinning.
correct, yeah.
So
But I
that's
think
funny. It's not intuitive to me.
no, it wasn't to me either. In fact, I was quite surprised by the
Yeah.
result. But I think it's just because it was so severely oversampled. We live in an area where the seeing is not that good.
Right. So you're really not losing any spatial because it wasn't there to begin with. It was already.
Exactly.
Okay. Okay.
So I think the increase in signal to noise ratio was the dominant factor and made up for that decrease in sort of the fake spatial resolution.
Yeah, yeah. I think BlurX can put in the fake special spatial resolution. It can see through the seeing in a way.
Yeah, when it's doing the deconvolution.
Yeah, exactly, exactly.
Yeah,
That's cool. Okay.
yeah. I even ran an experiment with Noise Exterminator. I grabbed some screenshots of that. That might be a future thing too, where I've seen some people do Noise Exterminator way at the beginning, which I do. Some people do it later on.
Hey there.
Sometimes they split it.
Where
Sometimes
are
they
you?
do some
In
in
my
the
office. Oh, okay.
There you go.
I just got home.
There you go.
some in the beginning, some in the end. And one time I did the same steps, except I just did the noise exterminator at the beginning, noise exterminator later on, like well into post-processing
Mhm.
after it was stretched. And the noise exterminator first, earlier in the process, gave significantly better results when I did it as apples to apples as I could do.
Yeah. My impression was that software is trained for linear, running in the linears,
It is.
because the one I built is actually trained specifically to run in nonlinear. It's just harder to collect linear data to train on.
Oh, that's interesting.
Yeah.
So it would make sense from that perspective. So Ubersmooth would work better on a stretched image.
Yeah, because all the images I was training on, like NASA images and stuff, they were already processed in the nonlinear state. So I don't have a good data set of like other people's linear data. I don't have enough data set of clean linear data to train the AI on. So, but I'm guessing RC Astro does have some access to something, maybe.
Yeah, probably. Now I often do a little bit on the back end so that if I have it, especially when I'm shooting here in my backyard, because it's it's Bortle 6 or something, so it's not a great site. And a lot of times I don't have, 15 hours of data. I have 2 hours worth of data, and it's going to be noisy. I'm even shooting when it's hazy out because
Mhm.
you still get something. It's still cool stuff.
Yeah.
And uh, in that case, a lot of times what I'll do is I'll do a mid-level noise reduction at the beginning. Then I'll do the processing steps. And then I'll do a little bit like a really low-level noise reduction at the very end to just clean up a little bit of that granular stuff that winds up being in the really black space. And that seems effective. So even though it's nonlinear data and I'm using noise exterminator, it seems to handle it fairly well. But I'd be curious what their experiences are with that in terms of when they do noise exterminator, when they don't, and what kind of results they've gotten.
Hey, Gary.
Hi, Steve.
Yeah, I've always done the noise exterminator early in the process. It's just, I don't know whether it's right or wrong, but I find I'm better doing that.
You do it early. I know, Bill, you have mentioned before you've done some stuff at the back end successfully. Like we're not like the very end, but I mean later, not early in the process with noise exterminator. Or no?
Yeah, I do noise at the very end.
Okay.
That's the last thing I do before I move it over into B. If I recall, linear is histogram, or is that not histogram?
Linear, it would be pre-histogram stretch.
Right. So when I take it out of linear, that's right. The last step before I take it out of linear is to put in noise reduction. I live with the noise. I like the noise in there when I'm editing because it shows me characteristics I can't see otherwise.
Okay. But it's still linear data.
Yeah.
Okay. Yeah. So that's basically what I did with this M13. The last step before I stretched it was the noise reduction.
Yeah, I wanted to ask on that too. I saw an email the other day that PixInsight team put something inbound, like within their standard processes, that's kind of like a noise reduction. Is that what I read? Let me see if I can pull it up.
Yeah, I'm not familiar with that. I'm still actually using an older version of PixInsight. Brett's going to be mad at me, I know, but that's okay.
Well, they had the issue for a bit, so I don't blame you for that one. MLD noise. So this came out 2 days ago. MLD noise.
I thought that was only running on Mac
Is that what it is? I didn't read any.
CPUs. There was
Yeah,
an
looks like
odd something I picked up. Yeah.
Yeah, I didn't even know they were on Mac. That's great. Because that was one of the reasons why I didn't get a Mac when I was getting a laptop, because they weren't there yet. Huh. Well, that's good to see.
That Paul, you're saying that's only on that platform? Only on a Mac platform?
Yeah, they're going to release in July.
The current beta, where they're starting, yeah, they only got it running on the Mac hardware.
Does
I think
anyone
it's to
here use
come.
the Mac? Has anyone used it?
I haven't used it.
I'm guessing they would port that over. They'll probably make it cross-platform like the other tools.
I think they will.
Yeah, it's a preview. I'm reading the email and it says we'll release a new version of MLD Noise for Mac OS and Windows next July. So should be next month that they release it, but it's a preview essentially at the moment.
I see.
Cool. Yeah, I saw the email. I didn't read it until now. So
Same here.
Hey, I have a separate question. Gary, you ever use this? I haven't used this yet. This Canon neural network.
I have not.
It's a paid software, but I haven't looked at the price on their website, but I see it through Google and it says it's somewhere around $5 a month. I was just curious if you used it.
No, I haven't. No, I did see that. In fact, I saw it the other day because there was some kind of security mail I got from Canon, and I looked and they said to download the newer software. But
Great,
and I
that's
did
what I
see
was just
that.
doing.
I don't know, didn't know what it was though.
Yeah, I was just doing that right now, downloading the updated utility.
Yeah. That EOS utility, I guess, had some kind of security breach.
Yeah. So, I don't know. I was thinking about checking it out. Maybe just give it a spin. It's helpful for next month's talk, like something like that. You know, the denoise is very helpful for when you're doing those kind of shots.
Oh, from the for your Star Trails kind of talk. Yeah.
Of which, if you don't mind, like the image I was trying to share in email.
Yeah.
I don't have a Flickr account, so I apologize. Because these things are too big for email. But here's what I took in South Carolina.
Oh, wow.
And I thought, I was hopeful that, so when I go through this, and I'll show next month, like, it's really, really, really tedious and takes forever. But I go slide by slide and remove all of the trails. So all the satellites and planes, but I missed one. And it's in the middle, like in the bottom near the center of the North Star area. It's like it jets up probably about, I don't know, maybe a tenth of the way up. And it's, yeah, that was disappointing to see.
You gotta redo it, Bill. I mean, I'm sorry, this is unacceptable.
So that's what I was trying to show.
That's beautiful.
Yeah.
Well, you
that's a cool perspective. What were the posts? What were like?
So
were they part of events? What were they?
This is at my in-laws. It's the only time I could ever get this shot because what they are doing is they're putting a roof on their dock. So it was out in the lake, and they live on Lake Wateree, which is like Waterloo, something like that. It's out in northwestern North Carolina, right south of Charlotte, and that area has they have, you know, they live on the lake, and they just put in a dock, but the dock didn't have a roof yet. It just came in today, so I'll never get this shot again. It's not like it's probably a Bortle. It's probably the same as Green Lane, probably like a Bortle 5.6 somewhere in there. But the problem is the horizons you don't have much of because the neighbors have some absurdly bright lights into the water, so you have to stay off the horizon. So when you look up, it looks good.
That's cool.
Yeah.
Anyone else have any images to share? I'm sure there's.
I do. I have a couple.
Yeah.
So my Star Trails don't look quite as good as Bill's over there, but
We'll
I did
fix
get
that next month.
I got an interesting one for my backyard. I'm actually not sure why the color came out the way it is. So I have the C Star S30 Pro. So I was just kind of trying it out, and I forget the exact exposure length for it. It's not very long, with it. You know, you can kind of see the rotation, but it was out for like an hour, I think. And I'm not sure, like I said, how the coloring came out. And also, like in the trees, there's this like weird green effect. So there's a lot of odd artifacts, but it
It's like
ended
you
up being
have
kind of a,
fireflies.
I don't know.
Looks like
Like,
fireflies in the trees. Go back to the trees.
yeah, I mean, it probably
That
is.
definitely looks like fireflies.
So it came out very artistic. So it's
Yeah,
definitely like an interesting picture, not what I was going for. And like, I'd like to clean it up a little bit because of those, but I don't think the Sea Star saves the individual pictures. So I don't think I can actually extract it and reprocess it. It only saves the end image, unfortunately.
Well,
So
there is a setting to save it each individual frame, right?
not for the star trails.
Oh, not for star trails. Oh,
Yeah, so I have some Milky Way shots that I have as well, and the Milky Way ones all have the subs, but the Star Trail one folder only has this output, so I don't think it does. And I got to figure out a little bit more, but you know, and here's an earlier picture of it, so you can actually kind of probably see some of the clouds that showed up.
Is it spinning? Is that what it's doing?
No, it sits still.
How long
It's
is
just
that? That's a very long shot.
It's multiple shots. It stacks them. It's only 10.
Okay, I
Yeah,
got it.
it's only 10 seconds, but it just stacks it for however long you're running for. And then the other kind of annoying thing is it doesn't have a way for you to say only run for like an hour. So I can't just leave it out overnight and say, okay, let it run for like 4 hours and I'll get it in the morning. It would still
Yeah.
be running when I wake up and it would just wash the whole photo out. So there's some limitations to it, but you know, at least was trying to experiment with it a little bit. So I got those. Um, and that was at my house. And then I went up to Hickory Run to go camping, and so I decided to try out the Sea Star a little bit, and was then trying to look at some Milky Way shots as well. So I haven't processed any of those, and you know, there's a
Oh,
very
there you go.
faint. Yeah, it's
Yeah.
very faint. It actually doesn't show up as well in this application. Like when CSAR saves it off on like your phone, it actually is more visible in the ones that it saves off. And I don't quite know why it looks different on my phone than it does on the computer. But you know, it's definitely prominently there. You know, there's a lot of sky glow from the looking south from Hickory Run.
Yeah, that looks really good.
Yeah, so and then that one's
Yeah,
a bit higher.
Yeah, that makes sense. You know, when you get off the horizon.
Yeah. So like it was only 9, it was like 10:30 when I started. So it's only about an hour, 2 hours, but this was still actually early in it. But it's partly because I didn't feel like getting eaten by the bear that night. So I didn't stay up too late because there was a bear roaming around the campground actively.
How was the campground for using any of these tools? Was it bright? Was it?
So I did it. I was there during the week, and for the most part, there wasn't anybody in there. I mean, they have that new bathhouse, and if you're looking directly at the bathhouse, the windows, you know, have light in it, but it doesn't glare at all. So, you know, from an astrophotography perspective, it wasn't a problem at all. I mean, the problem is in that one loop, you know, if you're taking long exposures, a car could drive out away at any moment and you know get washed out for that minute, so there's no way to protect it, but it still wasn't bad for the week that I was there.
Nice.
Oh yeah, I had a yeah, so you did it from the campground, right?
Yeah, I did it from it's the winter loop. It's like the 300 series
I
one.
haven't been up there yet this year. I usually do it from the lake.
Right.
And they put a light on the restroom. There it was constant last year. I just wanted to know if anybody been out to the lake, and I mean it's not bad, but you know it's just an additional light that doesn't need to be there.
Yeah, I did end up going over to the lake with it, so I can't answer that. I actually did want to, but Brett and I were actually planning on meeting up, but the weather didn't. The forecast didn't look good any night, and so it's kind of more just a luck that I had an hour or so type of thing that it panned out. So, and I also did this. This is IC 5070.
How long was that?
And at some point I actually have my C-Star S50 and S30 both taking an image of this at the same time. So I kind of actually want to do a comparative between the two of them, but I haven't processed any of it. And then, ironically, in the Milky Way shot, this is actually in the Milky Way shot because the C-Star S30 can actually take a deep field as well as a Milky Way simultaneously. So it actually will use both cameras at the same time. So I actually have 3 sets of exposures all at the same time frame, and I'm gonna try to figure out how to process.
Scott, how long was that exposure for that shot?
Let me see if I can find that real quick.
I feel like the S30 is probably better than the S50 for that.
Yeah, with the wider field. Yeah.
I'm shocked that they put a bad light up at that bathhouse because DCNR has been pretty good about what they've been putting up. That's disappointing to hear, especially with someone who's an astronomer there.
Yeah, it was just over in,
that was last year.
Scott, was this over in that Loop C, over in those high numbers?
Yeah, I was it's like 278. So
yeah. Yeah,
but,
well, that's the same area I was at, and it is bright. The bathroom lights are on.
Yeah, I mean, as long as you're above it, but
taking pictures, it wasn't a problem.
Yeah.
From
an exposure, it's 2,800 seconds. So however many minutes that is, my brain doesn't work.
42 is the number.
47 minutes.
Yeah.
So,
that's nice.
That's about right. I had about
filter.
40.
That's
this one I think had the filter turned on. Yeah, the name of it has the LP, so it's got the filter. And they were only 10-second exposures. And I had to kiss an Alt-Az. I don't have the equatorial set up yet, so just kind of. It was more or less. I took it with me. It wasn't a camping trip specifically to do it, but I took it and just took the advantage of the weather when I was there, kind of to just use it and things with it. So at least I got something out of it.
Very nice.
Yeah. So this one I'm especially interested in processing because I think, it'll pull out a lot more. The C-Star does a decent job of stacking, but, I definitely think PixInsight can provide a lot more data than what it stacks natively. So.
Yeah, I think for a nebula, you probably do a little better job than C-Star. C-Star does a good job.
Like I said, it's interesting. On my phone and iPad, these pictures look better. So I don't know if the fits just doesn't save quite as well as the JPEG for some reason. But if I pull it up on my iPad, it looks a lot more vibrant and everything, especially the Milky Way. So
it could have some different meta details in there.
Yeah. But as Gary said, unless you're like truly zooming in on it, on your iPad and your phone, you get to show it off, and no one's going to notice the graininess on it at the initials parts of it. So.
Yeah, you can tell the filter's on because it's red, like the stars are red.
Yeah. So, I'll process it and post it at some point.
Give it a shot.
Yeah.
That's all I had.
I know, Doug, you had that picture you posted with the the elephant trunk. I think it was, right?
No, that wasn't.
Oh, no. I'm sorry.
That was the Tulip Nebula.
Hold on.
SH2. Here, I've never shared my screen before. What do I have to do?
Oh, yeah, the Tulip. Yeah. That wide field.
Okay.
Yeah, that was nice.
Here, just a second. I'm not sure if I have it. Because I did something to it. What do I have to do to share a screen, or am I not set up for that?
Screen, you should see a share.
There's
share.
Bottom, a little up arrow.
Yeah, okay. Select a window of software. Okay. Yeah, I just took the image, and I told you I have no ethics in what I do. I just flip the color channels in the GIMP. And this was a narrow band image. And did that come up for people?
Yeah.
It looks cool.
Yeah. And I'd say it's a pseudo SHO image. But I think in terms of like seeing the detail in the nebulosity and the LDNs. I mean, that's what it accomplishes.
Yeah,
I mean, I
love
took a giant step. On the other hand, you could say I took a giant step backwards from reality on this one.
Well, with narrowband, I mean, that's kind of like what is reality at that point, right?
Yeah. So
No,
that's it.
I love the detail on this. Like the contrast is just great.
Oh yeah, that was anyway, this was Green Lane. It was Green Lane on the night of the 15th, and I just wrote out, I took advantage of it. It was cloudless from sunset to sunrise.
Wow.
Which I didn't
Right.
which was great. So I took advantage of it, used narrowband. I had a hype, so this was C6 with a Hyperstar and a mono camera. Oh, and one more thing.
Doug, you had a bunker?
Hyperstars don't
I
have
think he is.
filter wheels, so this device came in handy. If you can see it when you
The
swap
hair
filters
dryer?
out. Yeah, yeah. The image would not have been possible without it. It was very dewy out there.
Yeah.
Okay.
How many filters did you use with this one?
I used an HA, an H alpha, the Silicon 2, the Antlia filters, and the O3.
So you did all
I'm
three
not sure the
SHO, 'cause,
sulfur
yeah.
did. I'm not sure for the sulfur did much for it, but it was
That's awesome.
yeah. And
That's nice. That's a
Yeah.
cool shot.
yeah. So I thought, yeah, it was a beautiful. Oh yeah. So like I said, it was a beautiful night at Green Lane, and I got to see it all.
Mhm.
There you go. I'll turn that off.
How much exposure time is that, did you say?
That is like 90. Well, I got more. That's like 90 frames altogether at 90 seconds each. I had some more frames, but I tossed them because a couple of instances of my mount losing its mind. But altogether, it's like 90 seconds, 90 images of 90 seconds each on the Hyperstar, which is like f2.0.
Okay.
So,
That's cool. Great,
Yeah.
great job.
oh, thank you. Thank you, guys.
That's cool. You can definitely see the tulip in there. So
Yeah, yeah.
Yeah.
That's a neat
Oh,
target.
I guess I have one I can show.
Yeah, yeah.
Got a few in process, but one that's finished.
okay, it's up.
You see that?
Yeah.
Yeah.
So this is IC 4603 and IC 4604. I don't even know if I know how to pronounce this. Ro Afiuchi.
Oh, yeah.
Anybody?
Fucus.
How you
Or
say it?
Fuki, yeah.
Yeah.
Row up. Oh,
So it's I'm just looking for some unique challenges, I guess I could say. This is with the C-Star S30 Pro at Starfront. 20-second subs, and it's about 5 hours worth of data. I
That's
was hoping to get more of the blue in the top nebula, and I struggled with that, but this is what I ended up with anyways for now.
that's really cool.
hold on.
How dark is it there? Do you know what the
They claim Bortle 1.
oh, Bortle 1, okay.
Sometimes I think maybe it is, but we've gone through a rainy season of several months where very little imaging has been able to be accomplished. And I'm hoping that, things would start improving now.
That would be like 30 hours anywhere else, right, of time to get that.
I imagine, yeah.
Yeah, that's
Listen,
great.
not
Amazing
to
how much
diss,
stuff is
yeah.
going on in there.
not to diss Starfront, but they have some pretty extreme weather down where they are.
Well, this is true, but they also have some good prices. So I started there last August and had fantastic weather through January,
Mm.
and then it's been pretty bad. And I know they're right about in the center of Texas. I have a brother who lives in Dallas. So, I do know that there's seasons, and this has been particularly bad because of some El Nino or El Nino or one of those Ninas. And I'm just hoping that it clears up again. We get several months of good weather, which we had last year. It was fantastic. So I mean, this is just a little less 30, and to be able to get some of these details to
Yeah, that
me
texture is cool.
is just
That's so cool. Yeah.
amazing to me.
That's such a cool looking complex, that row Fukai complex.
Yeah.
Yeah, I've always wanted to shoot
Oh,
that.
there I see. Yeah, I just
That's
pulled
one
it
of
up
Joe
on
Land's
Stellarium.
favorites, I think. Joe has shot that a number of times with a camera lens on an astronaut on his D. I think he has one of the D6s or something like that.
Yeah.
6Ds.
Kind of have to be in the right place for that one.
Yeah. He's done it up at Cherry Springs. I know he was shooting it a couple years ago when we were up there. It's just such a rich complex.
It's a tough time of year at Cherry Springs because usually May is, it's just not
It's
reliable.
not high enough, right? It's too soon.
Well,
Right. This is in Scorpius, right?
Ofukai
I mean, it's in Ophiuchus, but
Scorpius.
it's sitting right above Scorpius.
So
Yeah, I think it's in the
like this is the
Serpent.
best time. Right now is the best time to be going at it. But it's just May and June are at Cherry Springs, they've rolled the dice.
Yeah, yeah.
So, Bill, have you had some luck with this one?
No.
Oh, okay.
I want to.
You're
I'm
implying that
envious.
you
I'm very envious.
Okay, sorry.
But
Yeah,
good
that's
work.
great.
Looks great.
Beautiful job, Steve.
Yeah, thanks.
Yeah. That's one you could look at just for hours, just
Oh,
stepping
yeah.
and pulling it apart.
Right.
Yeah.
It's amazing.
I wound up running a little experiment just for the heck of it. I long time ago, well, not that long ago, and 9 years ago, when we were in Wyoming for the total solar eclipse in Casper, we took a day trip up to Devil's Tower. And I think I had shown this picture a couple times in like some of the workshops of Devil's Tower. It's a composite of Devil's Tower with the Milky Way behind it. And I processed that 9 years ago using the tools I had at that time, which was Photoshop and a stacking processing software called Images Plus. It's kind of like the PixInsight now. It used to be one of the leading astronomical image processing software packages back then. And at that time, I did the best I could. I didn't have in Photoshop, it was before they had the auto masking where you could just mask the sky out. So I actually bought like a little tablet with a pencil so I could literally erase in between the branches of the tree. It took me about 4 or 5 hours just to get rid of the sky in this picture and have the branches look real. It was just painstaking process. And I dug my heels in. It's like, I'm not giving up on this. I'm going to do it. I'm going to do it. So about 3 weeks ago, I said, let me look at that same data with software that just makes the sky go away and PixInsight. And I wound up reprocessing the image with the new tools. So I can share that real quick. It was actually I'm really happy with the new image. And for years I loved the old image, but now when I look at the old one, it's like, what was I thinking? So let's see. So share. So this is the before.
To your desktop.
Hey, Gary, I'm curious about how you process this in PixInsight. I've been tempted to put regular camera stuff in PixInsight, but
I used the
Look at the
I used the raws from the Canon RAW. I'd opened them up. So this is the before, which I've always been really happy with this image. This to me, I mean, it brings me back to that evening. We were in the north parking lot of Devil's Tower, and I shot it with a tracker and a 10 millimeter lens on a crop. I had a 10 to 22 millimeter zoom on a crop sensor camera. It's my old 50D. And I was always really happy with that picture. We wound up, we were going to stay till like 10 o'clock. We left at like 2 in the morning or something.
You don't mind me asking, what's the light source for Devil's Tower?
Devil's Tower was shot during twilight. So I waited till after sunset and I shot Devil's Tower. There was like the Belt of Venus behind it. So it's actually a daytime or twilight picture that I brought way down in
That's awesome.
exposure. I didn't add any color to it. That was like picture like in between the golden hour and the blue hour kind of thing. It was that. So it was still some golden hour stuff going on. So that's that.
That foreground is amazing. It really carries that picture.
Oh, thank you. Thank you. This is the new one. Same data. I changed the image scale. I changed the height a little bit. I added a little more foreground because I wanted it in this like 16 by 20 kind of aspect ratio. But if you look at so it's a little bit different framing, but the Milky Way to me looks just so much more natural.
Yeah.
Now the whole thing, that's cool. It's very dramatic, but that to me just looks it just looks so much more natural. And the other thing is when you look at these, this is with the auto, get rid of the sky.
Yeah, so sharp.
How good a job it did.
Yeah. Yeah, it does a great job. You know what? Your original image, the thing I like about it is, first off, there's two things I noticed. There's the original image. It has the your patented your love of black point, because you got this thing down. I know you got this thing down from starting point. You got the black initiated, and then you started building out. I mean, that's what it feels like you did.
Yeah, it is. Yeah.
And I know that's your style, and it's cool. It's cool to see it here. And then the other thing too is, for the old one, I love how the Milky Way actually complements the color scheme of the rest of it. It's not natural, but it to me is more put together. Like it kind of feels, like it's the same color palette or something. I don't know.
Yeah, it kind of blends better to you. Yeah.
I'd say that the original's more visually like what you would see, because you don't have as much color visually. So it matches more what you see if you were there.
Yeah, the other one's great too. There's really no bad one here. Like, these are both amazing. You have all that green. Look at all that green.
When you process a pixel, did you reduce the number of stars?
No,
It looks like there's less stars in this one.
Well, it's just because there's less contrast in it. And I did actually two versions. One is a little contrastier, and then it has more of this darkness here, more of the black, and the stars pop out more. But here, there's actually more stars in this. It's just that they're not as in your face. So it's a weird thing, because I hear what you're saying, because I still like that picture. That's just a cool picture to me. And then I look at this and I think how smooth it looks. This has a much smoother kind of look to it, but it doesn't have as much punch. To me, that has a lot of punch.
To me, that, what that reminds me of. Now we're kind of removed from it, right? Like, it's weird to think I don't know, maybe this happens all the time. It's just weird to think 10 years ago, or not even 10 years ago, you have this kind of retro, with the technology, you have this kind of retro embedded style, kind of like you would have with, actual film. And this has, the original one has that. And a new one, when you did this, like, did you just put the star pieces in the PixInsight? Is that what you did? You took out all the foregrounds and just dumped the star parts in? Like, how'd you do that in PixInsight?
I literally just stacked the image. There's only like 10 images or something. There's very little data in terms of the Milky Way. They were let me look at that. I have it right here. Hold on. I'll look at my lights. Oh, here we go. So there's,
Because with the sky moving, I feel like PixInsight is going to merge the land or do something to the foreground.
it did. And then I moved the foreground to block that. So it's actually blurred. So if you look at so I have 12, there's 12 images, 12 Milky Way shots in there. So there's only like six minutes of Milky Way. I mean, this is really dark. Devil's Tower, there's not much up there. So it was really dark sight. I don't know what the Bortle was. I didn't have a light meter back then, but I could probably look it up now. But I'm guessing it's 1 or 2. It's a dark area, and it was late at night. It was around midnight. We were, like I said, we were supposed to be there till around 10 o'clock. We bought some hoagies and we are going to hang out and just look at it. And we wound up staying there till about 2 in the morning. And then it's like a 2.5 hour drive back to Casper. So we were floating in at 4:30 in the morning or something. Dead tired. But let me see here. I'm
Yeah,
just going to pull out what came out of PixInsight.
So yeah, when you put it in PixInsight, it's going to move the land because it thinks
This is what came out of PixInsight.
right, it has to move with the rotation.
That's what came out of PixInsight.
So what did you do here to get that Milky Way into the other shot? That's what I've always worried about on PixInsight.
I took this.
Yep.
I took this. This has a transparent background, even though it doesn't look it, on the screen. Oops.
Right.
Ah, stop it. Get this out of there. Get some stuff out of the way here. So I took this image. That's my processed foreground with the sky removed. So anything black here is really transparent. If I put that in Photoshop, it would be transparent. And then I just moved it. I moved it up so that it was blocking this stuff. So I lost a little bit of the Milky Way.
Okay.
And you can see it's the same. I have the PixInsight. I have the Photoshop file here. This is the easiest way to show it, I think. So there's the background, there's the foreground. So I left, you can see a little bit of the blurry tree here.
Mm-hmm.
Doesn't quite get covered, but it looked like part of the Milky Way, and I didn't want to lose more of the Milky Way.
He scooched it up a little bit, I guess.
Yeah, I just scooched, yeah.
Nice. Yeah,
Yeah, very cool.
that works.
So, yeah, I mean, it's all, it's a composite, so it's kind of like
Cool.
whatever, judgment call you make. But I just thought it was kind of neat to see how much better the Milky Way, how clean it looked with the newer tools.
Yeah, 6 minutes of data. That's amazing.
Yeah, it's really not much at all. Anyway, Where's the stop share thing? Hold on.
Don, you need to write a AI that can take care of satellites. It should be fairly easy, right? Like all you're doing is a heel on lines.
An AI that has a laser beam and shoots them down?
No, for images, it should be.
I'm just kidding.
It should be relatively easy though, because they're usually a fixed length, and they're usually the same. Like they're a variant of a similar color, right?
Yeah.
And all you would need to do is, I say that loosely, is you're essentially healing what's there.
Yeah, the way you do it is take good images and then you draw what looks like it on there and you present the AI the pairs.
I have enough satellites. I don't think.
Yeah, I'll hit you up for the data set.
Yeah, if you need it, like I was looking at the ones from. I went up Cherry Springs on Friday, and I have so many satellites. It's unreal.
Right. Are you doing individual images like
Yeah,
exposures?
just looking at the camera shots.
Yeah. If you're stacking, you can get rid of them, but if you're not stacking, good luck.
I don't even know if you can get rid of these. I don't know. There's a lot. So many. I mean, this is wide field. This isn't.
Yeah. If you have enough images, it'll do a good job. The only thing I've seen it not get rid of the artifact rejection is if it's like a really bright plane.
Yeah.
Sometimes they're close and they got the red light and the green light and and then the headlights, and good luck with that. Just dump that frame. The number of satellites though is getting out of control. No matter where you shoot anymore, there's just like every third frame has a satellite in it now.
I would say every frame.
Almost every frame you're seeing them?
Yeah, I haven't shot with my 80mm telescope yet, but with the C-Star, maybe every fourth frame, like you said.
Yeah.
But a camera, it's every frame, every single frame.
Because of the wide field.
Yeah.
Yeah. Wow.
Even when we were doing visual out of Green Lane the other night for the club, I could see you just see them. It's fine.
Yeah, I was doing.
Oh yeah.
Ready to go up again. More of them. It's gonna be nonstop.
Yeah, we'll see. I mean, I was looking visually last year through Markarian's chain in that area, and it was just like satellite bomb nonstop. It's like, come on, out of all places, just my field of view is so small.
Right.
The other night I was shooting red, blue, and green. It was that Friday that was excellent a week ago or so. And I started with red. There's only one out of 20 that was usable for the satellites. So I've got to stagger the sequence so the beginning of the night doesn't get wiped out from satellites.
Maybe we should go in and we should buy our own satellite and we'll cover it with sea stars, and that'll be our own. The weather's always good.
Yeah, we can putty them on the outside.
Yeah.
A little bit of silly putty will work.
Yeah. Don't mess up. You can't fix it though.
There's money to be made for someone who can create the AI that gets rid of these streaks.
Oh man.
That sounds like a challenge, John.
$5 a month.
John, yeah, I mean, it could be $5 a month. You never know. This is pretty.
Hey,
How
Mark.
many $5 a month are you getting there, John?
What? I'm not getting anything.
Oh, okay.
Yeah.
Yeah, that adds up. In a year, you have $60. That's a lot.
Yeah, that's true. I have gotten some, so I appreciate all that I have gotten.
Okay, Scott, what do you got?
Well, so I took the Milky Way that I was talking about earlier. I've been trying to process it, and it kind of comes out washed out now. So I don't know, like processing wise, why it kind of just doesn't really appear very well. So
did you do the color calibration?
Yeah, I did the color calibration at the beginning.
Yeah, it looks like it did a good. Yeah,
it's actually right there. There's the color calibration.
And then you re-stretched it linked. You did the screen stretch linked.
Well, the which one?
Well, after you color calibrated it, the screen transfer, the STF auto
link it.
No,
You
no.
link that, you click the linked button and then stretch it again, and then do the auto stretch.
Okay. Well, because I was further along, like now I was trying to actually do the histogram curves and all that, but no, I didn't do the linking with the screen transfer.
Yeah, that's something that when after you calibrate, you should do that because that'll keep the channels the same relative. That'll mess up your colors if you don't. It'll make it look funky if you don't
Okay.
do that. It won't matter when you do the real stretch, the
Yeah.
histogram.
Well, that's what the histogram looks like
Unless you
now.
unlink the channels, but
I mean, that's what the histogram looks like now.
Do you have an ultra wide monitor?
Yes.
yeah.
I was like, this is wild.
I don't normally share the whole monitor.
No, it's
but
cool. It doesn't fit in mine. That's all.
No, it's real narrow. It's
That's funny. Yeah.
here,
it's like
yeah.
ultra letterbox.
Yeah.
Yeah. No, well, actually, I know what I could do.
Share just that window. Oh no, that
That was the window, but I had
that
pictures
was the window.
like,
You'd have to shrink
oh.
you'd have to shrink it.
There you go. Is that better? That fit in a little better for you guys?
There you
See,
go.
I can't see what you guys can
that
see
looks a little better.
Yeah, that is.
per se. Yeah, it's a 49-inch wide monitor. So normally when I screen share, I only share a single. But Pixen's like for some reason always just goes full screen.
Yeah.
Like it doesn't like to stay half a screen. So but yeah, so offhand I'm not quite sure what I mean, I know what this is up here. This is an artifact from a tree. But yeah, I mean the rest of it just kind of seems, I guess, how do you reduce the number of stars? Because it seems like there's just a lot of excessive stars.
Well, you would, if you separate the stars, you could stretch them less.
Okay.
If you did like a star extraction,
Yeah.
using StarNet or something like that, or Star Exterminator, you could then not stretch them as much, and that would
Okay. So Star Exterminator, you just create the star image, stretch it, and then add it back later.
Yeah.
Okay. Maybe I'll try to do that because yeah, I had done. I know it's gonna mess it up if I do it right now, but if I do Star Exterminator,
It'll take a minute.
yeah. Well, it doesn't take too long.
Yeah, with the small images, the C star stuff,
That's a good point.
Pretty fast. Yeah.
Yeah.
Yeah, it's only 21 by 3800.
When I'm doing the drizzle stuff with the big camera with the APS-C, I do the star extraction with the large overlap. If it's a dense star field, it sits there for like 3 or 4 minutes. It just cranks away.
What's large overlap for?
It increases the it does it in panels, like little segments.
Okay.
And it just increases that overlap.
Oh, the tiles. Yeah.
Yeah, the tiles.
Yeah, I noticed in the image that it has a swirl effect too. So I'm not quite sure if that's just an artifact of the C star stacking everything, but you can see a swirl pattern.
It's from the alt. That's field rotation from the alt.
Yeah.
You're not running in an equatorial mode.
No, not when I did it. So
yeah, you can't get rid of that. That's field rotation.
Okay. Yeah, so I'll go back and do some of it, but yeah, it is kind of a little bit odd, the coloring and things. So I'll see what I can mess with. But I was messing with it while we were on the call just to kind of get a little bit further to see how much, data I could pull out from it. So
yeah.
Was the filter on when you shot it? It looks almost like HA and O3 colors.
Hold on.
Oh, maybe like you're thinking the dual band filter was on the LP filter?
I was wondering,
yeah.
So would that be in the FITS file?
I'm not sure.
Because you did your photometric color calibration with RGB. So just double checking it matches what actually you're shooting with.
Hold on. C star.
Let's see.
Milky Way. I doubt the filter's on because I don't think you can turn the filter on
It
the
says
C
no
star.
filter in your file name. 10-second
Uh,
filter and no filter.
no, that's PixInsight, and when
Oh,
PixInsight,
never
when
mind.
you're doing the weighted
Got it. That's
pre-process, you
something
tell
else.
it if there's a filter and stuff. But
Yeah, that's not from the C Star. Got it.
Here's the Fitz header. Whoop, where'd it go? I don't know if it'll tell you if I had a filter or not. There's the camera.
Yeah, I'll tell you if you have filter.
Yeah, which field? I don't think it is though. I'm pretty sure when you're doing the wide field, like the Milky Way one, I don't think it's an op. Yeah, it can't be. It's on the
it wouldn't be. Yeah,
it's on the wide field lens,
Okay.
so it doesn't
Okay.
have
Yeah,
the filter
yeah.
on the wide
Yeah,
field.
that's
fine,
only
but
on
yeah.
the telescope.
Yeah, only on the narrow.
Gotcha. Cool. Checking.
So, yeah, well, I'll play around with it more with it, but it's kind of one of those interesting that it wasn't quite going as easy as it's supposed to go. It's not like it's not like when you do it, Gary, where you make it seem so easy.
It's like a cooking show with Gary.
Exactly. It's like, oh,
Yeah,
here we have risotto. It's so easy to just make some risotto, and everyone else makes it. And it comes out terrible.
To answer your question about the filter, the header, I just opened up a Fitz header from the telescope, and it does show you the filter.
Okay.
I had shot the horse head, and it automatically put the LP filter, and it's in the Fitz header. So, yeah, but you're right.
But that's not from the C Star though, right?
Yeah, C Star S30 Pro.
Okay.
Yeah.
Yeah. Like I said, like some of the other ones, the file name includes it, but the Milky Way and the Star Trails is kind of an oddity to how ASI CWO implemented it. Like they have it, but it seems like it's missing a few features. Like it's kind of like grafted on the side. So still a little bit learning curve on how they did some of that stuff. So, but okay. Well, I think I'll take a stab at it more and see. I also stacked 3 sets of files, and I'm wondering whether the camera moved between one set of them. So, because like I did a set, and then I know I did another set, and I thought the camera didn't move, but I'm wondering whether maybe it moved, and that's why it kind of isn't as clean of an image set, that it's not all the subs from a single stack that the C Star did.
Yeah, and that's going to increase that field rotation problem.
Right. Like I'll just shorten it to use just a single one. I just have to figure out like where the line between the 2 sets of images was.
Yeah. Usually about 20 minutes. I think Tom Nolasco did some experiments. He found about 20 minutes. Anything more than 20 minutes of total exposure, the field rotation starts to become too big a problem.
I didn't think about that with the Milky Way as much. I mean, I know I had that with the S50 some, that you can see it actually on the edge of the image, that the edge of the image gets really fuzzy. Yeah. But in here, I wasn't seeing anything, and I let it run, like I think, like I said, 40-something minutes, 45 minutes. So I'll have to see whether it really affected it badly. So I'll just get a single set of shots and go from there.
Yeah, you could do maybe a subset or something.
Yeah, like I said, I was outside and I took a set and then I paused. I took a set and paused and did a third one, and of course it dumped all of them into a single folder and trying to figure out like, okay, where's that exact time window? I got to go back and say, where's the time one, and only grab these files and see what it does. So, cool. Hey, it's at least data that I can process now.
Yeah, exactly.
So.
Well, we're at our limit or our time thing here. So if anyone has anything else, if not, we'll I guess shut off the
Let's have the stream. Good night.
Thing. Thanks a lot, Gary, for the info. I got a couple sheets of notes.
Yeah, and for your RGB, basically there's one extra step at the beginning, right? You do the RGB combine, and then you follow that same exact workflow. So you don't process the RGB separately and then combine them. You combine them and then just do the gradient correction and then this color calibration and all that stuff. So it's really just one extra step.
Okay, I gotta stack them first before I combine
Oh,
them.
yeah. Yeah,
Yeah.
yeah, you're gonna stack, yeah, yeah, yeah. You do all that pre-processing. I'm just talking about the post-processing.
Yeah.
There's one more, there's like one more step in the linear phase. That's before the gradient correction, and that's just combining the channels.
All right, thanks a lot, Gary.
Okay, take care.
care.